Hello everyone. In previous lecture, we have seen some numericals related with universal law of gravitation and acceleration due to gravity. Now, today we will discuss the new topic, that is, what do you mean by mass and what do you mean by weight? That is, also we have seen the difference between mass and weight. How the mass and weight of an object be different from each other. Is why these both things are different from each other and what is the difference between it. So first we will see what do you mean by mass of an object. Now mass. So whenever we talk about the mass of an object, so what do you mean by mass? So mass is nothing but the quantity of an object, the quantity contained in the body, which is regardless of its volume and the force applied on it. So what do you mean by mass? Mass means it is the matter, that is the matter or the quantity of matter in the body. For example, suppose we consider this chalk. So if this is the object, so this chalk is consist of a matter, consist of small number of particles. For example, if we talk about the paper, then this paper is also made up of large number of particles, so it contains some matter. Pen, if we consider the pen, then it is also consist of matter. Matter means a small number of object, a small number of particles. So if we consider any object, or if we take a smallest and the smallest particle of an object or of this chalk, if we take as the smallest particle of the chalk, then it also contains some matter. So the mass of an object is nothing but the matter contained in the body. So if we say that it is an object, means that object has a body, and if it has a body, then it contains some matter, and therefore that is called mass of an object. So what is mass of an object? Mass of an object means the quantity of matter contained in the body, and this quantity of matter is regardless of its volume. So it does not depend upon the volume or any force applied on it. So it is regardless of its volume and force applied on it. So that is called mass. It's called as mass of an object. So what is mass? Mass means the quantity of matter contained in the body. How large is the body or how small and smallest is the body, which is regardless of its volume. If the body is large, then it has a volume, but if it is a very minute object, then it has a volume. It has also a volume, but it does not depend upon the volume is large or less or anything. So the quantity of matter, whenever we talk about the smallest and minute particle also, so those object, whenever we call an object, it has a body, and it has body means it has some matter contained in it. That is called the mass of an object. So mass of an object means the quantity of matter contained in the body, which is regardless of its volume and the force applied on it. That is called mass of an object. Now, as we have already learned that the mass of an object is a measure of its inertia, means greater the mass, greater the inertia, less the mass, less the inertia. And therefore, mass of an object is cannot be zero. So here we are say that the mass of an object can never be zero. So whenever we say that it is an object, then that object has some mass. Though it is very less, it is very minute, it is very negligible, but it has a mass. So there is no body in the universe which is massless. So we can say that mass of an object can never be zero. So this is the most important part, that is mass of an object can never be zero. So mass of an object can never be zero. So every object has certain mass. Though it is negligible, though it is very small or it is large, it doesn't matter. But there is no object which is massless. So mass of an object can never be zero. And another important thing is that the mass of an object all over the universe remains constant. So if we consider only the mass of an object, then that mass of an object on the earth, above the earth, at pole, at equator, or on the Mars, on the moon, on the Jupiter, or any planet, the mass of an object in the universe remains constant. So mass of an object never be changed place to place or planet to planet. If we consider the mass, so this is if we consider the mass of the chalk, or if we consider the mass of this duster, the mass of the duster or mass of the chalk, mass of the paper, mass of the pen, it remains constant. It does not change place to place. Place to place means on the earth, on the equator, on the pole, on the Jupiter, on the Mars, on the Saturn, everywhere. Everywhere in the universe, mass of an object remains constant. So the important thing is another, that is mass remains constant. So why mass of an object remains constant? It remains constant everywhere in the universe. So mass of an object remains constant, or mass remains same everywhere in the universe. So why it remains constant? Because it is independent of speed, acceleration, volume, or applied force on it. So mass is the quantity which is independent. It does not depend upon any kind of speed or velocity or acceleration or the force applied on it or volume or anything, any external factor. So mass of an object is independent of all these external factors, and independent means it does not depend upon all these external factors, that is speed or velocity or acceleration or force applied on it. And as it is independent, it does not depend upon all these factors, therefore it remains constant everywhere in the universe. So what is mass? So this is the important thing about the mass, that is mass is nothing but the quantity contained in the matter or in the object or in the body, or we can say it is the matter contained in the body, that is which is regardless of its volume or force applied on it, that is called the mass. Again, another important thing is that mass cannot be zero. Why mass cannot be zero? Because it is given in its definition. Because why mass of an object cannot be zero? Because every object has a body, and that body is made up of matter. Though it is very large or though it is very small. But whenever we say that it is an object, it is a body, then that body is made up of some matter, and that matter has some mass. So mass of an object can never be zero. And mass of an object, why mass of an object remains constant everywhere? Because it is independent of all the external factors like speed, velocity, acceleration, force, volume, etc. So all these factors does not affect the mass of an object, and therefore mass of an object remains constant everywhere in the universe. Now what is how the mass is measured? Mass is measured with unit kg or gram. So SI unit we can say kg and CGS is gram. So how we measure the mass? Mass is measured with or we can say SI unit of mass is kg, and it is a which kind of quantity? It is a scalar quantity. Mass is a scalar quantity. Now already in first chapter we have learned about the scalar and vector quantity. So scalar quantity means the quantity which have only magnitude and it does not require direction, and vector means those are required magnitude as well as direction. So mass is the quantity which does not require any direction to measure, and therefore it is a scalar quantity. So mass is a scalar quantity. So again one another important thing, that is the mass of an object is the measure of its inertia. So inertia is totally depend upon the mass. If mass will be more, then inertia will be more. If mass is less, then inertia will be less. So that is called mass of an object. So mass of an object is denoted by capital M or small m also. So mass of an object is denoted by capital or the small m. So this is about the mass of an object. So we can say that its SI unit is kg and it is a scalar quantity. It is a scalar quantity. So these are the important points regarding mass. Now we will move towards weight. What do you mean by weight of an object? Now, whenever we go to the grocery shop or in the hospital, mostly when we visit to hospital or visit to doctor, we are very eager to measure our weight. We just pull the weight machine and just stand on it and see our weight. So mostly this happen with us. So here what we say that we measure the weight. In a grocery shop, we measure the things, that is sugar, then tea powder or anything. So we measure the weight. We not say that we are measuring the mass. Okay. Are we use the word that is please measure sugar or please measure the mass of the sugar? No. We are measuring weight of that object. So what do you mean by that weight of an object? So we all know that the earth attract everything towards earth with certain force, and as the earth attract everything towards it with certain force, because it is depend upon the mass of an object and the acceleration due to gravity. So what is weight of an object? So weight of an object is the force with which the earth attract towards itself. So weight of an object is the force with which it is attracted towards the earth, and therefore we can say that weight is the force. So weight is the force with which weight of an object is the force with which it is attracted towards the earth. Or we can say weight is the force, or we can say weight is the force which is act by the gravity. That is also called the weight. And therefore this weight of an object. So weight is nothing but the force, and what is force? Force is nothing but mass into acceleration. But this acceleration is nothing but the acceleration due to gravity, because every object get attracted towards the earth. So why every object get attracted towards the earth? Because of the acceleration due to gravity, and therefore this acceleration get changed by g, that is acceleration due to gravity. So F is equal to mg, but this force is nothing but the weight of an object. So weight of an object is nothing but the force with which it is attracted towards the earth, that is called as weight of an object. So weight of an object is, the formula for weight of an object is mg, and the weight of an object is denoted by W, capital W. So weight of an object is denoted by capital W, and its formula is W is equal to m into g, where m is the mass of object and g is acceleration due to gravity. G is acceleration due to gravity. So that is called weight of an object. Now, what is the SI unit? So SI unit of weight is mass is measured in kg and acceleration due to gravity is measured in meter per second square, and kg meter per second square is nothing but Newton. So as the weight of an object is nothing but the force, and force is measured in Newton, so weight is also measured in Newton. So SI unit of weight is Newton. So as in commercial life, as we are talking about the weight, so that weight we are measured only in MKS unit, that is in kg, but actually the SI unit of weight is Newton. So SI unit of weight is Newton, but as we are go for an grocery shop or to measure our weight, it should be in an kg. It is that is nothing but the commercial unit that we are using it, but the actual SI unit for weight is nothing but the Newton. Because why it is Newton? Because weight of an object is nothing but the force, and as force of an object due to gravity. So it is force of an object due to gravity, and therefore the weight of an object, SI unit of weight of an object is Newton. And as it is an acceleration due to gravity, as we know that acceleration due to gravity is always move in a downward direction, so the weight of an object is also in a downward direction. So what is the direction of weight of an object? Weight of an object always act in a downward direction. So if any object is hang, then its weight, then its force is always act in a downward direction. Why? Because weight of an object is the force with which it is attracted towards the earth, or it is the force due to it is the force of an object due to gravity, due to acceleration due to gravity, or due to the gravitational force of the earth. And therefore the weight of an object is always act in a downward direction. Why? Because acceleration due to gravity is act in a downward direction, so weight of an object is also act in a downward direction. It means that the weight of an object has a direction, and therefore it is a vector quantity. Therefore it is a vector quantity. So weight of an object is a vector quantity. Now, is the weight of an object is same at all places, just like a mass? No. Weight of an object changes place to place. Now, why the weight of an object changes place to place? It is given by the answer is given by its formula, m into g. Weight is mass into acceleration due to gravity. Now we know that mass of an object remains constant, as already we have learned. But what about g? If we talk about the acceleration due to gravity on the earth, then on the earth acceleration due to gravity will be different. At pole and at equator it will be different. At the center of the earth acceleration due to gravity will be 0. Means if we talk about only the earth, then is the acceleration due to gravity is constant? No. On the earth acceleration due to gravity will be 9.8. At the pole it is highest, at the equator it is lowest, and at the center of earth it will be 0. So if we talk about the earth, then acceleration due to gravity never be same. Then is how the weight of an object will be same on the earth or on the another planet? So acceleration due to gravity of moon will be different. Acceleration, that is value of g for Jupiter, will be different. Then acceleration due to gravity on Saturn will be different. So as we change the planet, acceleration due to gravity gets changed. And as the acceleration due to gravity gets changed, then weight of an object also get changed place to place. Though the mass of an object remains constant, but the value of g gets changed place to place or planet to planet. So as the value of g gets changed, then the weight of an object also changes place to place. So weight of an object never be constant. It changes place to place. As mass of an object remains constant everywhere. Why? Because it is independent of all the things, that is speed, velocity, acceleration, force, all these things. But weight of an object is dependent of all the things. It depends upon the speed or velocity or acceleration. Here also we already see that acceleration due to gravity. So as the value of acceleration due to gravity gets changed, the weight of an object get changed. So the weight of an object never be constant. It changes place to place. Again we say that mass of an object can never be zero, but weight of an object may be zero at the center of the earth. So what is the acceleration due to gravity at the center of the earth? At center of the earth, the acceleration due to gravity will be zero. Then what about the weight of an object? So though that object has certain mass, but its weight may be zero because of acceleration due to gravity. So any planet or any place where the acceleration due to gravity is zero, at that place the weight of an object may be zero because of acceleration due to gravity, not the mass. It has certain mass, but its weight may be zero. It is only because of acceleration due to gravity. So this is the important points regarding weight of an object. So from this we can easily differentiate mass and weight. Hope you understand the concept of mass and the concept of weight of an object. So mass is nothing but the quantity of matter contained in the object, and the weight is nothing but the force. Weight is nothing but the force which always acts in a downward direction because it is attracted towards the earth. So weight of an object is the force with which it is attracted towards the earth, and its formula is W is equal to mg. Mass is denoted by m and weight is denoted by W. Then the SI unit of weight is Newton, but the SI unit of mass is kg. So here we can easily differentiate between mass and weight. So now we differentiate two things, that is mass and weight of an object. So we will see the difference or distinguish between mass. Distinguish between mass and weight. So here there is a mass and here there is a weight. So first point is regarding the definition. So I don't write definition every time. So what is the definition of mass? Mass is nothing but the quantity of matter contained in the object or contained in the body, which is regardless of the volume or the force applied on it. And what is weight? Weight is the force or weight of an object is the force with which it is attracted towards the earth. That is called as weight of an object. Now the second important point regarding mass and weight. So mass can never be zero. So a mass can never be zero. But here we can say weight may be zero. So why weight may be zero? Because of if at the place where the acceleration due to gravity becomes zero, at that place the weight may be zero. Then third, mass remains constant all over the universe. So if we place the duster on any planet, then its mass remains constant, but its weight may vary place to place or planet to planet. So the object will be same. So object will be same, but for that object the mass remains constant, but its weight get changed. And why its weight get changed? Because of acceleration due to gravity. So third point is weight changes place to place. Then fourth, mass of an object. So mass of an object is independent of external factor, that is the speed, velocity, acceleration, force, volume, etc. But weight of an object is depend upon all these external factors. So here it is independent of external factors like speed, velocity, acceleration, acceleration, etc. And here we say that it depends on external factors like speed, velocity, acceleration, etc. Then fifth point, it is a scalar quantity, it is a vector quantity. And sixth point, its SI unit, its SI unit is kg and its SI unit is Newton. So this is the difference between mass and weight of an object. So hope you understand the difference between mass of an object and weight of an object. If we consider any same object, then its mass remains constant all over the universe or any planet, but its weight may get changed place to place. So on the earth, the weight will be changed. At the pole or at the equator or on the moon or on the Jupiter, the weight of an object changes not because of the mass, it is only because of the acceleration due to gravity, because the formula for weight of an object is W is equal to mg. So always remember what is the formula for weight of an object is mass into acceleration due to gravity. So your mass remains constant but your g get vary, and as your g get vary place to place, then the weight of an object get vary place to place. So hope you understand the concept of mass and weight of an object. Thank you.